Hello my dear student, welcome to my video again. This is video number 3 pro permutation, combinations and binomial theorem. Let's start from the next question. Okay, in my last video I have done question number 16. Now let's select another different question. Question number 19. Okay. Question number 19 asks, which of these numbers has exactly 6 permutations of its digits? That means some numbers have been provided. A 334, 758. B 748, 536. C 333, 333. D 333, 373. Okay, we have to determine which number has the exactly 6 permutations. We have to assume we are shuffling all these 6 numbers, because question says which number has the exactly 6 permutation for its digits. That means we have to assume it is shuffled all 6 numbers. Okay, let's firstly look at this. All numbers are same. If all numbers are same, how many times we shuffle? All arrangement look like same. What is the meaning of permutation? That means number of different arrangement. But we cannot get the different arrangement from here. Only single arrangement are possible, no? That means right away the answer is 1. Number of possible arrangement is 1 for this, okay? Okay, for the future, remember that if you see the equal numbers or equal letters, then number of permutation is always 1. We don't have to substitute in the formula. Although you use the formula, you are getting the 1. That is one thing. But this is not the answer, no? We are looking for answer 6. We are looking for the answer 6. Answer 6 means we are looking for the final answer 6, value 6. Let's check with this. Here we have to use this formula. Factorial n upon a be like that. At the beginning I mentioned that out of n numbers, out of n items, if there are repeated items, when you shuffle everything, this is the permutations. Okay. What is n? N is total number. 1, 2, 3, 4, 5, 6. 6 factorial. What is A? A is the one kind of repeating numbers. 3, 3. Okay, 3 is repeated. That means A is applicable to. Once we simplify this, what is the answer? 6, 5. 4 factorial 2 like this. 2, 1. Okay. But when you simplify, you are getting the different number. This is also not 6. What about this? Here all numbers are different. All numbers are different means n is equal to 6. R is equal to 6. Because here we have to apply this formula, NPR. When all numbers are different, you have to apply original formula. Okay? That means answer is 6p6 factorial 6 upon 6 minus 6. That means we are using this formula. NPR equal factorial n upon factorial n minus r. Okay. What is the answer for this? Factorial 6. 6 minus 6, 0. 0 factorial is 1. Factorial 6 upon 1. That is something else. This is also not 6. Okay. We check with all these options. A, C, B, we are not getting the answer of 6. Then definitely we are getting the answer from this. However, let's check for our knowledge. N is equal to 5. 3 is repeated 5 times. Sorry. N is equal to total number. N is equal to total number. 1, 2, 3, 4, 5, 6. N is the total number. Then A is applicable. There are repeating number. 3, 3, 3, 3, 3. 3 has been repeated 5 times. That means the parameter A is applicable. A is equal to 5. There are no other repeating numbers. Then B and C like that not applicable. Then answer is factorial 6 upon factorial 5. Okay. We apply this formula. What's the answer? 6 times factorial 5 upon factorial 5. Actually, I did not explain this much. Now we already know about how to simplify. Factorial 6 is equal to, we have to arrange 6 times 5 times like that. But after 5, we can consider this as the factorial 5. These two cancel. Now we are getting the answer of 6. Okay, this is the right answer. The right answer is option number D. Okay, D. Answer is option number D. Okay, now let's move to other question. I would select question number 22. Question number 22. Question number 22 says, there are 4 red plates. There are 4 red plates. Red 4. 2 green plates. Okay. Okay, being a different question actually, this time I elaborate this. There are 4 red plates and 2 green plates. Okay, this question is impressive just to understand the concept. There are 4 red plates, 2 green plates. How many different ways can plates be stacked? You have to stack all these plates. You have to stack all these plates in order. How many different ways? This is, of course, no? What is N? Total number. 6. N is 6. Now there are 4 repeating numbers. There are 4 identical plates. 4 red plates. That means, let's assign A for that. A is equal to 4. There is another identical plates. 2 green. That means B is applicable here. B is 2. Now let's apply this formula. Factorial N upon factorial A factorial B. Now let's input this value. Factorial 6 upon factorial 4 factorial 2. Yes, you can simplify this at your convenience. That okay. How to simplify? Selecting convenient method. You know how to expand this. Starting from 6, 6, 5, factorial 4, because I saw this one as a factorial 4 in the bottom. Okay. 6, 5, rest of the numbers factorial 4. Now top part is completed. 6, 5 factorial 4 divided by factorial 4. Factorial 2 is 2 times 1. Okay. 2 is 2 times 1. These are cancelled. 6 times 5, 30. 30 divided by 2, 30 divided by 2, 50. Answer is 15. Answer is 15. That is, answer number is A. Answer number is A. Okay, now let's select another question. I will go question number 25. Question number 25. What it says, question number 25. How many three-digit combinations? It is clearly said. How many three-digit combinations are there of the digit in the number 39517? This is very straightforward. Actually, through this question, we are able to understand the concept of the combination. Because they have given us a combination. That means we have to select group only. Okay, that means 3 digits. We have to select 3 digits only. We don't have to align. Order doesn't matter, okay? That means, what is n? N is the total number. 1, 2, 3, 4, 5. Total number is 5. The selection number is 3. R is equal to 3. But this time, we have to use the combination formula. NCR. NCR. Now let's use the formula for the combination. Factorial n upon factorial r n minus r. Otherwise, you can use the calculator directly, okay? Pi C3. We are looking for pi C3. Factorial 5 upon factorial 3. 5 minus 3 factorial 2. You can simplify this. 5 4 3 factorial divided by 3 factorial. 2 times 1 is 2. Now this is cancelled. What is this? 5 times 4. 20 divided by 2. Answer is 10. Okay, answer is 10. That means answer number is D. Answer number is D. Right at the beginning, actually, in order to understand the concept, you have to elaborate. You can elaborate this formula. But your teacher out, no matter, you can directly get this value from the math function in your graphing calculator. Okay. That is question number 25. Now let's do question number 28. Question number 28. There are 17 points on the circumference of a circle. How many lines can be drawn to connect all possible pairs of points? There are 17 points on the circumference of a circle. Okay, this is the first time actually we do the diagram in this kind of question. Okay. There are 17 points. There are 17 points. 1, 2, 3, 4. Like this, we don't have to mark all the points. How many lines can be drawn to connect all possible pairs of points? Actually, this time question has been asked indirectly. But we have to apply. We have to select which kind of combinatories we have to put. Why did I say combinatory? Both of permutation and combinations are called combinatories. Combinatories. Okay, that means we have to select the right combinatory, either permutation or combination. What you have to select actually? Number of lines. That means we have to group 2 points. This is one line. This is one line. This is one line. That means out of 17, at a time you have to select 2 points. Out of 17 objects, you have to select 2 objects. Drawing or not drawing the line, it doesn't matter. Physically, we have to draw the line. Just concept is actually out of 17, we have to select 2 items. We don't have to align. That doesn't apply here. Okay. That means this is a combination question. Answer is 17 C2. Out of 17, we are selecting 2 points and joining. Joining doesn't matter. Let them to do that. Okay. Yes. Now let's simplify this. Now here note actually, if you look at here, I am teaching you some different thing. Okay. NCR, this is like this, factorial n upon factorial r n minus r. What is n? N minus 1, n minus 2. We have to write up to here after that. Okay, no problem. Let's learn this later. Let's go with this now, okay? It is easy to use the formula here. Factorial n. Okay, let's use the formula. NCR equal factorial n upon r n minus r. N is 17. R is factorial 2. N minus r means 17 minus 2. That means 15 factorial. Okay. That means we don't need to go with the another formula. I will let you know that this time. Okay. Let's expand this. Now you know how to expand this better than me. Okay. So start with 17. 17, 16. Rest of the product is 15 because I observe 15 here. Divided by factorial 2 means 2 times 1. Now what happened? This, you have to write this 15 again, okay, before cutting. Now these two are crossing. 16 upon 2, 8. 8 times 17. When you calculate this, you are getting 136. Okay, there is an answer for 136. There is an answer for 136. That is, answer is B. Answer number is B. Okay, now let's look at the another question. Question number 29. Question number 29. Which expression is not equivalent to 3C2? 3C2, which is not equivalent. A. Okay, let's expand this. If you use the formula, that is factorial 3 upon factorial 2 factorial 3 minus 2. Because I apply this formula. N upon r factorial n minus r factorial. When you substitute n is equal to 3, r is equal to 2, we are getting this. That means this is yes. Yes means there is an answer A for A. This answer A is look like this. That means this is yes. That means this is equivalent to this one. That is right. Let's go to B. This is A. B says like this. 3p2 divided by factorial 2. What is 3p2? For 3p2 we can apply this one. In PR equal factorial n upon factorial n minus r. That means instead of 3p2, we can apply this formula. N equal 3 divided by n minus r means 3 minus 2 factorial 2. Okay. This also okay, no? This is same as 3c2. Finally, we get this answer. This is also right. A, B, C, sorry, C, 3c1. Let's simplify this. 3c1 factorial 3 upon factorial 1 factorial 3 minus 2. Let's simplify this. Factorial 1 is 1. Factorial 3 upon, what do remain in the bottom? Factorial 1 is 1, 3 minus 2 is 1, that is factorial 1, that is also 1. Final answer is factorial 3. I think once you simplify also, you are getting factorial 3. Okay. Let's simplify one of this answer. 3 in the bottom you have 3 minus 2, 1. That is 1 factorial 2. This is equal to 3. Okay. Factorial 3 upon 1. 3 minus 1 here. Sorry, 3 minus 1 factorial 2. Then answer is 2. Okay, I explain this again. 3c1, we are using this formula, NCR, factorial 3 upon factorial 1, factorial 3 minus 1. That is factorial 3 upon factorial 1 is 1, 3 minus 1 is 2 factorial. This is equal to 3. Okay, that means this is also right. All A, B, C right. What is D? D is given some nuisance thing actually. Remember these two notations are same. NCR, these are same, okay? These are right. Some people are using actually this notation. Notation is right, but N and R are different. N should be located here. If this were 3, 2, that is right. If this is like this, that is wrong. Okay, these are wrong answers. Because N cannot be less than R. Okay, that means this answer is not equivalent to this. All other 3 answers are equivalent to this. That means right answer is D. Answer is D. Okay, what is next question? Let's look at question number 34. Some different question, okay? Question number 34, that says solve for n in the expression. Solve for n in the expression NP4 NC4 times NC4 is equal to 11,700. Okay, let's solve for n. Actually, this is some kind of algebra question, okay? This is a kind of algebra question. Let's use formula. What is NCR? Here we have to use both of this formula. NCR equal factorial n upon factorial r n minus r. That is for this one, that is for the first part. For the second part, you can use NPR is equal to factorial n upon factorial n minus r. Okay. Let's apply this combination formula for this plus part. Okay. Factorial n upon factorial r. R mean factorial 4. Factorial n minus 4. That is for first part. Okay. This is this one. Times. For this one, factorial n upon factorial n minus 4 is equal to this number 11,117,600. This is for this part, okay? Now let's use our knowledge of algebra. When you look at this, these two terms look like same. Factorial n upon n minus 4. Factorial n upon n minus 4. Then from algebra we can say like s times x is total s squared. That is one thing. We can separate 1 upon 4. 1 upon factorial 4. Okay, I would write 1 upon factorial 4 times. For the rest of the number I write factorial n upon n minus 4 factorial whole thing, everything is squared, is equal to 1117,600. Okay, please understand these are the separate, okay, this is a separate line. This is first step, this everything is my second step, this is a third step. How do you handle after that? How do you proceed after that? Let's multiply both sides by. Okay, I write this again in order to be clear. Now let's isolate this part. Let's try to isolate this part. That means let's multiply both sides by this denominator, factorial 4. This is not 41, okay, factorial 4. N upon n minus 4 factorial, whole thing is squared equal 117,600 times factorial 4. Okay, let's find this number. Let's calculate this number from the calculator. That is factorial 4 times. Factorial 4 I will write directly. 4 factorial, that is 24 times 117,600. Okay, I got a big number. 2,822,400. What happened? That is, this everything is squared. This everything is squared equal to this number. That means only this part, n upon n minus 4 factorial is equal to square root of this. Now let's proceed after that. What is the square root of this? I would take the square root. Okay, that is a whole number. 1680. Now let's simplify this. N minus 1, n minus 2, n minus 3, after that n minus 4 factorial. Because we have to expand this like this. Starting from n, subtracting 1, just write the multiplication. N minus 1, n minus 2, n minus 3. Once you read the number equivalent to bottom, then you can proceed with the factorial sign. Divide by n minus 4 factorial is equal to 1680. Now you can cross this and this. N minus 1, n minus 2, n minus 3 is equal to 1680. Okay, this is a kind of difficult equation. After that, we are getting the polynomial function. The solving polynomial function is difficult in this stage, but we can use any other alternative method. One way to do is answers are given. You can substitute any of these answers. What answers have been given? 8, 9, 16, 8. I don't know why mistake this both are 8. That doesn't matter. We can try it one number. If we put 9, what will happen? 9, 8, then this one. Okay. 7, 6. Let's see, we are getting this number once you multiply. Okay. 6, 7, 8, 9. 6, 7, 8, 9. Okay, that is 3024. That is not getting this one. Let's try with 8. 8, 7, 6, 5. 8, 7, 6, 5. Yes, we are getting the answer. This is the right answer. When you apply n equal to 8, we are getting the answer. Even though this is not a multiple choice question, you can use the guess and check method, because we have to substitute some reasonable value. Okay, n is equal to 8. The answer is A or D, doesn't matter. Answer is, let's say, D. Okay, let's do one more questions. Question number 38. This is the last question I am supposed to do under +2 section, permutation and combination. Okay. Question 38. This says, after sports tournament, every player shake hand with every other player once. Okay. Every player shake hands with every other player once. That is important thing. They are shaking hand one time only. If there are 36 handshakers in total, that means answer is 36. 36 handshakers. How many players are in the tournament? Okay. There are players are in the tournament like this. Let's say number of players are n. We have to find the value of n. They are shaking hand like this. This person needs this, this person needs this, this person needs this. But they are not shaking hand 2 times. That means we have to combine 2 persons only 1 time. Then what's the combination? Combination is NC2. Number of shaking hand is NC2. N is the number of people. 2 is the people are joining, no? When they shake hand, they are meeting 2 people. NC2. NC2 value is equal to 36. Number of shake hand is equal to NC2. That shake hand number is 36. How many players are in the tournament? We are looking for n. Okay, we have to solve this equation for n. Let's expand this. factorial n upon factorial 2 n minus 2 is equal to 36. After that we can write factorial 2 is 2 times 1. Let's keep this aside and expand this. N minus 1. After reaching n minus 2, let's stop. Because bottom number is n minus 2 is equal to 36. Now simplify. Let's multiply both sides by 2. If you multiply both sides by 2 and by crossing this n minus 2, we are getting n minus 1 is equal to 72. Let's expand this. N squared minus n. N squared minus n equals 72. N squared minus n minus 72 equals 0. Now this is a quadratic equation. Let's factor this. You can factor this easily. S minus 9, s plus 8 is equal to 0. That means n equal 9, no, n is equal to negative 8. Right answer is n equal 9 because 9 is a positive answer. Yes, that is option number D. Answer is option number D. Okay, we have discussed actually some number of selected questions, more than 20 questions under combinatories, under permutation and combinations. Actually, we have not covered most of the things. If you try actually other short answers and written type question, you are able to catch more questions. Okay, see you in next video. Then I will do the binomial theorem in next 1 or 2 video. Thank you very much. See you again.